Okay, so you have seen that how the current under current flowing through the coil under commutation, how that varies with time, and for different instance we took 5 different instance, and how the current varies in these 5 different instance. So am I audible clearly?
Yes, sir.
Okay, if my voice breaks, you just point out. Okay, so these are the area. So we have two areas under the brush. Uh, Under the brush which is in contact with commutator segment 2 is defined as A2, and the area of brush which is in contact with commutator segment 3 is defined as A3. And as for the time instant, first time instant, that is instant 1, the brush was totally in contact with commutator segment 2. So therefore the A3 we can take as 0. Now in the next instant, when the slightly the brush moved towards uh, the segment 3, then only a small portion of the commutator segment 3 will be in contact with brush, so we can take that is less than the contact with A2. Okay, so this is how we have changed the areas A2 and A3 with respect to time. At the end, the total contact will be established with commutator segment 3. So therefore, the A3 will be 100% and A2 will be 0. So this is how the areas under this changes. And if we, okay, so let's see the expression. Now, if we have the expression of the coil current like this, that we have derived in the last class, that is IC, uh, though it is an approximated value of the coil current, so we did some approximation. Okay, so if this is the value of this current, now for different instance, what are the value we can get? So let's see. Now, if we take the time instant 1, so what will be the value? If A3 is 0, so that means it is IC. Okay. Now, what is this value? A2 greater than, or take a particular time instant when uh, only the 25% is in brass in contact with 3 and 75% of the brass is in contact with 2. Then what will be the value of the coil current? Can you tell me? So I have taken only
IC by
25%.
2.
The brush has moved towards the commutator segment 3. So that means 25% of the brush area is in contact with commutator segment 3, and the rest, that means 75% of the brush area is contact with commutator segment 2. So what will be the value of IC, or the coil current under commutation?
IC by 2.
IC by 2.
So that means IC by 2. Okay, so that
2.
means what is the value of A2 if we take A2.75 and A3.25? So the numerator will be zero point 0.5 and the denominator will be 1, isn't it? So 1 minus zero point 0.5, that is 0.5. So that means 0.5 IC, or IC by 2. Is that clear? So how it is coming IC by 2? Okay. Now, if we take the instant, this instant as 3, if this is instant 1, so this is
0.
and this is instant 5, and intermediate instants are 2 and uh, 2 and 4. Okay, so a2 equals to a3, so it is very simple. From this is 2 a3 by 2 a3, that is 1, so 1 minus 1, it is 0. Okay, now let us see what we'll get for the instant 4, and we can make the same assumption for this also, like this assumption we made for 2. That is, in the instant 4, the 75% of the brush area will be in contact with 3, and the rest, or 25% of the brush area, will be in contact with commutator segment 2. So what will be the value of this coil current? Can you tell me that? Okay, so in the
Minus IC by 2.
75 into 2, so that means 1.5, isn't it? And in the denominator it is 1. Always it is 1. A2 plus A3, always it is the total brass area. So 1 minus 1.5 we are getting. So that means how much we are getting? Minus 0.5. Okay, so that means the same value will get with the negative sign. So that means minus 0.5 means minus half, isn't it? Is it clear? Okay,
Yes, sir.
okay. And at the end, that is when the brass will be totally in contact with 3 and A2 is 0. In that case, we'll get what we'll get, that is 1 minus 2, that is minus 1, because the numerator will be 2, because this is 1, and so this will be 1 at the end, this will be 0, and this will be 1. So 2 minus 2 by 1 is 2. So 1 minus 2 is minus 1. So that is minus IC. So this is how the current uh, current flowing through the coil under commutation gets changed from IC to minus IC, isn't it? Now, we have taken, so this type of thing we are getting. So that means we are getting almost linear commutation, isn't it? So this is an ideal case, but not the practical one, because here we have done some assumption which may not be valid. That means what is the assumption we made for this analysis? Anybody? What are the
Sir, we
assumptions?
neglected the we considered the coil resistance to be very small. So the RC by R2 plus R3 we neglected, which was in the denominator.
Okay. Now, if it is not the case, then what will be the change? So let's see. So where we did the assumption, we just find out that step uh, where we made the assumption. I think here, isn't it? In this step, we made the assumption. Okay.
Yes, sir.
So after this, we have proceeded with the approximated value only, and the denominator we have neglected. Okay. So here only the numerator we have taken. So if we proceed with the original one, that means this one. So what will be the change in the expression? Okay, so that means we have only proceeded with the numerator. We haven't considered the denominator. If we would consider the denominator, so what kind of change we can expect? Okay, so let's see the first case, that is when the A3 is 0. Okay, so if A3 is 0, the okay, so let's see. If A3 is 0, the numerator becomes 1 only. What about the denominator? Any idea? If we don't consider if we consider the coil resistance, in that case, what will be the change in this current coil current expression? Anybody?
স্যার সেম থাকবে।
Why? Can you explain that? For you are saying for instant one or
Yes, sir.
all instance? I'm asking only for
Instant
instant
one
one now.
when A3 is 0, then IC.
A3 is 0, then
So IC will be IC same.
I see.
IC it is same IC.
Okay, so that means then no question of this R2, isn't it? Sorry, no question of R3. So
Yes,
R3
sir.
won't come. So basically, it will be IC only because there only the contact with the commutator segment 2. The brush has not moved towards commutator segment 3. So that means it will be IC only. Okay, so now what about the next instant? That is instant 2. So that means when the brass is in contact with 3 as well as 2, but with 3 only 25% contact as established, and with 2 75% contact is already there. Now the numerator, as per the numerator, we should get IC by 2, isn't it? But we have to now consider
Yes.
the denominator as well. So if we consider the denominator, apart from this numerator, we are having this denominator, and denominator we can say is always more than 1, isn't it? So that means exact value, if we
Yes, sir.
don't consider also, we can say at least this coil current must be less than IC by 2, isn't it? That we can say, because this is having the denominator which is more than 1, because 1 plus RC by R2 plus R3. This is always is a positive value. So it is always more than 1. So denominator, additionally, we are getting the denominator, and which is more than 1. So therefore, it is always less than IC by 2. So have you understood this point? Have you all understood this point? Why?
Sir, I have a question. Sir, I have a question, sir. Sir, at the first case, why you are neglecting the denominator? Only R3 is 0, but there is 1 plus RC by R2. So why are you neglecting that particular denominator?
Which one? In the first, case you were
In the
asking?
first case, yes, yes.
No, that
Yes,
RC
sir.
RC by R2 by R3 is much less than 1, so therefore you have neglected that. So here we have written already. So this is
Sir,
this is the ground of
in
Actually,
this denominator.
excuse me,
sir,
sir. Sir, actually, he was asking for the second case that we are calculating, where IC is less than IC by 2 in the second case. Before that step, when A3 is 0, then we said that even in the resistance commutation process, IC will be IC. So, but in the denominator, there is an RC term present. So, what happened to that RC in the resistance commutation case?
No, in
sir,
the resistance. Okay,
in
so
the
that term will not come at all, because that is there is no contact with 3.
Yes,
Okay,
sir, but RC is
sir,
there. RC is still
sir, excuse
non-zero.
me.
so
Sir,
R3 is
sir,
0.
excuse me. I want to tell
Uh,
something.
uh,
Sir, in the first case, A3 is 0. So we can think that R3 is actually infinity because R is inversely proportional to A. So that's why RC by R2 plus R3 is 0.
That way also you can say, if you are sticked in this expression, then you can say that this is inversely proportional to A3, and as A3 is tends to 0 at that point, so you can say that is almost tends to infinity. And if we put something infinity in the denominator, okay, so that means this term will be
Okay,
0.
Okay, okay, sir.
Have you
okay,
understood?
sir.
Okay, sir.
Thank you. Yes.
Thank
That
you.
way
Yes.
also you can think, or you can think just like only the current physically you can think that. So only the current is flowing through the commutator segment 2, and only the that current is carrying the whole current. There is no branching at all, isn't it? So if you see this instance, so when the brush is in contact with 2 only, there is no branching of current at all. So that means this whole IC is flowing through the coil undergoing commutation, isn't it? Okay. And if you understand from this expression, then you can think of this type of explanation. Okay. Now, what about this instant 3? So instant 3 is again the numerator. If the numerator is 0, whatever they are in the denominator, it will be always 0, isn't it? So that means this value will remain unchanged. That is 0 only. Now, what is the case for this step 4, instant 4? So again, if we stick with our numerator, so numerator will be unchanged, and that is minus IC by 2. But the denominator again will be more than 1, just like the instant 2. So denominator will be more than 1. Now what will be the value of IC? Is it less than this value, minus IC by 2, or more than this value? Anybody?
Sir, magnitude is less than IC by 2 in this
So
case
that
also.
means it is less negative, isn't
Yes,
it?
sir.
It will be less negative.
Yes, sir.
It is be less negative.
Minus
That means we can say it is more than minus IC by 2. This way we can explain this. It is less negative. So therefore we can say IC must be greater than minus IC by 2. And again, this value will remain unchanged. Okay, so this is the exact analysis, and this is the approximated analysis. Isn't it? Now, by this exact analysis, what kind of curve we should get? So that means the 0.1, 0.3, and 0.5. So these 3 points are unchanged. So this point, and this point, this is unchanged. So only the change is there in instant 2 and instant 4. So what is the change? The IC is less. So that means this instant the IC value will be less. Okay. And here the IC will be, sorry, IC টা less মানে নিচের দিকে হবে তাই না? It will be in this side. Okay, sorry. And this is less negative means this side. Let me erase this point. So am I right? Have you understood these 2 points? For instant 2, it is less than IC by 2. If this is IC by 2, because that is exactly at half, and this is minus IC by 2. So this is IC by 2, sorry, that is positive, and this is minus IC by 2. Okay, So that means we can approximate the curve like this. So this we can say the exact resistance commutation. Though the approximated analysis was giving us the linear commutation, but if we consider the resistance, coil resistance, then we must get this type of curve, which is called the resistance commutation curve. So is this clear? Is this clear? Let me see. We have 46 or 45 participants today. Oyon Query and Shushmit Rudro. Both of you unmute.
Yes, sir.
So are you attending the class regularly?
Yes, sir, attending the class.
Regularly you are attending the class.
Yes, sir.
Okay, Shushmit Rudro. Shushmit Rudro. Are you there? Shushmit Rudro. Okay, so you should check your device properly before attending the class, because otherwise it will be it is very difficult to communicate with you. Now I already told you that when you join the meeting, you rename yourself.
Sir, our audio is breaking.
Okay, so I am not discussing anything right now. I'm talking to them. So Ayon Kuide and Shushmit Ruddu, I am just asking you to rename yourself properly. Your name should start with your roll number, last 4 digit of your roll number. Like all your friends has renamed themselves. So you should follow those instructions to attend the class. Okay. Now, okay. So now, if we can, so we how many currents we have in this? We have two currents, or rather three. So what are the currents? Let me see. So that means one current is the current which is flowing through the uh, commutator segment 2, and that is I double prime, isn't it? And one current is flowing through the commutator segment 3, and that is, what is that current? 2IC minus I double prime. And the current which is flowing through the coil, that is IC minus I double prime. Now let us derive some expression for this current, this currents. Okay. Now, if we assume that, let me draw the commutator like this. So these are the commutator segments. So suppose this is 2 and this is 3. And suppose,
Sir, your voice is breaking.
okay. Okay, just give me some time. I'm just trying to reconnect. Am I audible now? Am I audible?
Now you're audible.
And the screen? What about the screen? Can you see the screen?
Yes, it's okay.
Okay, just a minute. So, what was I was trying to say that suppose what kind of chat? Okay, suppose it has x is the contact with the brush 3 and rest of the contact with brush 2. Now, if the peripheral velocity of this is vc, as we have taken last class, that is vc. What is the expression of vc? Can you remember how we can define this vt in terms of brush width and commutation time?
Brush width by commutation period.
So brush width by commutation period, because already we have defined tc. Tc equals to bw by vc. So that means vc equals to bw by tc, isn't it? Now how we can define this x? So x is nothing but vc into t, isn't it? At any time instant t, and this is the vc is the very peripheral velocity of this commutator, that is into t. So therefore we can write in terms of in place of vc, if we substitute that, so we can write brush width into t by tc, isn't it? So we can write this. So why we are writing this? Let us come to some blank position so that we can discuss. Okay, now what is the value of I double prime, and what is the value of 2ic minus I double prime? We'll find out all these values, isn't it? Though it is the value of the coil current. Now, what is these values? As per this uh, expression we have already derived. Anybody? Will you try? In terms of these, Hmm? You just try. What is the value of I double prime?
R2 plus RC times IC divided by
Hmm?
R2 plus R3 plus IC.
What is that? No, you just see. Uh, come to here. Okay, so you just see this. Now X, the current depends on the contact area, isn't it? The contact area between the commutator and the brush. The current depends on that. Now X slightly has, uh, so that means the brush has a very small contact with commutator segment 3. So so that means then that I double prime has created, isn't it? So what is the value of I double prime? So that I double prime, we can think that I double prime is proportional to X, isn't it? Okay, but what is the proportion of the current will flow through the that commutator segment in 3 in that instant? That we can write. So I double prime, what is the proportion? The total current is 2IC. Now the proportion is X and the total brush width is this. So this is the proportion by which the I2 prime will flow. You just see, try to understand this. So here your I double prime is flowing, and here your this current. That means what is that? What is this current? 2IC
2IC minus I.
I double prime. Okay, so we can write this here. So I double prime means 2IC X by brush width, and here it is 2IC minus 2IC X by brush width, which can be written as if we take the 2IC common, this can be written 1 minus X by brush width. Now this X by brush width again can be written like this. You see, from this you can write this X by brush width equals to T by Tc. So we can substitute the value of X by brush width. How? 2 IC minus T by Tc. Okay, so this is the exact expression of the 2IC minus I double prime. Now, what is the value of this? This is IC minus 2IC. Is this okay? So then, what is the value of this? If we can take this as common. So what will be this value? You just find out yourself. Okay, so this is IC minus 1 minus 2 T by Tc. So these are three expressions, and So have you understood? Have you understood this expression?
Yes, sir.
Okay. Can we explain it? Anybody? The first expression only, I double prime only. Can you explain? I'm just asking you, one of you. Oshmita Mukherjee. Oshmita Mukherjee. Oshmita Mukherjee. If I ask somebody and if he or she doesn't respond, I will just mark him or her.
হ্যালো
কোথায় ছিলে তুমি?
হ্যালো
অস্মিতা মুখার্জি?
স্যার হ্যালো
Are you
স্যার
there? হ্যাঁ, কোথায় ছিলে তুমি?
ইয়েস স্যার স্যার আমি তো হ্যালো বলছিলাম
হ্যাঁ, না তুমি তো মিউটই করোনি, আনমিউটই করোনি। তুমি তো অনেকক্ষণ ধরে মিউট করে রেখে দিয়েছিলে। Okay, so can you explain
হ্যালো
how we are getting
না
this
স্যার
idea of
আমি তো
prime? Okay, so leave it. You just explain how we are getting this I double prime. As I've already explained it. Can you explain?
নো স্যার I haven't understood it completely.
So that means you are not attentive in the class. Raisa Chatterjee.
Yes,
Can you
sir.
explain how you are getting this?
Um, no, sir.
Why?
Mm, Sir, it has been derived from the equation IC is equal to capital IC minus I double dash, and small IC is capital IC into 1 minus 2A3 by A2 plus A3. And we have substituted the values of TC is equal to BW by VC.
Now, how we are getting this expression 2IC x by BW? I double prime equals to 2IC into x by BW. How you are getting this expression? That I'm asking.
Sir, mm, I double prime will be IC, capital IC minus small IC. And then we are substituting the value of small IC.
No. Small IC
Which
is
is equal to capital IC into 1
small
minus.
IC. First, we have determined the value of I double prime. Then we have calculated this small IC. Let me ask somebody else. Doipayan Guho.
Yes, sir.
Can you explain?
So the total current from the two segments is always 2 IC.
Correct.
So right now we are
That means
assuming
that
the
is the
amount
brush
of area
current.
in contact with. Yes.
That is the brush current, isn't it?
So
okay.
yes.
Okay.
So right now we
Continue.
are assuming that the area of the brush in So we are assuming the area of the brush in contact with the third segment, commutator segment is X. So the ratio of the current coming from commutator segment will be X by the brushed width. So that's why 2IC to X by the
Okay,
bigger.
just like the interpolation method, isn't it? Or you can say the by the unitary method also you can say. Isn't it? It's very simple. When that is totally contact with 2, then 2 IC current. That is the maximum value of I double prime is 2 IC. Okay. And when it will slightly contact with 3, then how much current will flow?
It will be the ratio
X.
X
That is
by
the
the
X by
brush
band,
width.
X by brush width. যখন পুরোটা কন্ট্যাক্টে রয়েছে 3 এর সাথে তখন আই ডাবল প্রাইম হয়ে যাবে 2 আইসি, কিন্তু এখন তো পুরোটা কন্ট্যাক্ট হয়নি, এখন একটা ফ্র্যাকশন কন্ট্যাক্টে আছে, সেই ফ্র্যাকশনটা হচ্ছে এক্স বাই ব্রাশ উইথ। তাহলে টোটাল কারেন্টটার একটা ফ্র্যাকশন কারেন্ট এখন যাবে। If the total current value is 2 IC, then now only X fraction of that will flow. That is 2 IC into X by brush width. And the rest of the things are derived on. The small IC also derived value. Isn't it? So have you understood this point? Okay. Now we neglected many things, not only the resistance. So the resistance also resistance only we have considered here, but there are other few things we have not considered here, like the inductance of the coil. Now you will tell me that sir, this is a DC machine, so how inductance comes? Can you tell me how inductance can come in this type of analysis?
Sir, here during the commutation, the current in the coil changes from plus IC to minus IC. So actually, whenever current changes through a coil, so obviously the term inductance comes into picture because it changes the flux linkage.
Correct. Correct. So that
coil.
means if there is a change in current, inductance always oppose that. So by principle,
Yes,
inductance always oppose any change in current. How it opposes the change in current? It induces a voltage against that change, and that voltage is proportional to the change with respect to the time, isn't it? So that you know that that voltage which it induced, that is LDIB. So that you all know. Okay. Now that inductance which will come in this case will be not only the self inductance, it will be mutual as well, because if there are multiple coils under permutation, then the mutual inductance may also arise. So let us take the voltage which will be developed due to this inductance and the current change in the coil undergoing commutation. Let us take that voltage is ER. ER is the reactance voltage. Reactance voltage induced in the coil going under commutation. So let us take that is ER. Okay. Now this ER, what is the value of this? ER should be the self inductance into the change in current. Okay. Now what is this current? This current is the IC, the coil current. The coil current, current flowing through the coil going under commutation, that IC. Okay. Now the second the term which will come due to the mutual inductance. Mutual inductance means the inductance between the coil 1 and if other coil is also going under commutation and that is the coil number 2. So that is the mutual inductance between the coil number 1 and 2. That also will come. And we'll write this is IC2 because this current which is flowing to the coil number 2. And this we can take coil number 1. Okay. So this is how we can write this. This can be a series because we don't know how many coils are going under commutation. If coils are going under commutation, then we can write this expression like this. Any doubt? This is the reactance voltage induced or developed in the coil going under commutation. This is called reactance voltage. Do you have any doubt? You can point out. Okay. Now here the only the thing which is similar, which is same for all, that is the change in current. As the current change is always this plus IC to minus IC level. So always this DIC, whatever the value of DIC1 or DIC2 and DIC3, this is always same. And what you can tell me what is this value?
2 into IC.
Correct. So that means here the only two levels are there. That is IC minus minus IC. Because current is getting changed from plus IC value to minus IC value for all coils. For all coils, these two levels are fixed. Isn't it? So these two levels are fixed. So that means it is always 2 IC. This change is constant for all the coils. And dt also is constant. Can you tell me what is the value of dt?
TC.
Correct.
Commutation period.
So that is the commutation period. So this is the TC. Okay. So have you understood these points? Okay. Now, if we substitute this expression in the first expression, then what we'll get? Can you write? You just try to write it. Okay, so 2 IC divided by TC and the L1 plus L12 plus L13. Okay. And if we take this as an equivalent inductance, so then we can write this L equivalent. So if this total is, we can take within a single inductance, so it will be an equivalent inductance. So this is the expression for this reactance voltage. Okay, so we can also write like this 2L eq. Okay, and what is TC? TC also we know what is TC. TC is nothing but sorry, DC by BW, because 1 by TC is, we are getting 1 by TC. Okay. And what is the value of this IC? With the, if we if we know what is the value of armature current, what is the value of IC? Because
IA by
IA by
A.
IA by
A.
A. Number of parallel path.
so this is IA by A. So is it clear? So that means some constant, we can write some constant K into VC into IA. So all these constant will come under K. So that means K we can write equals to 2L EQ divided by BW into A. So this is the expression of reactance voltage. Now sometimes also we represent this commutator speed. You know that the armature and commutator, there is a difference in dia. So if this is the dia of the armature, the commutator dia is always less than this. So therefore there is a change, there is a difference in peripheral speed. Okay, but whatever the thing, sorry, this is DC. So whatever the thing, so that will be proportional. Okay, so that means we can write this VC by VA is DC by DA, and that is a constant for any machine. That we can stay constant for any machine. Okay, so that means by that assumption, we can write that this is another constant into VA into IA, where DA is the peripheral speed of the armature. VA is the peripheral speed of the armature. So this is the expression of reactance voltage, where the reactance voltage will be developed or induced in the coil undergoing commutation. Is it clear? Now, this is the reactance voltage. Now, the another thing which we can consider here, if there is some voltage in the commutation place, then due to that voltage, there will be some uh, voltage develop, and that voltage will be called the rotational EMF. So have I explained the term rotational EMF or speed EMF before?
No, sir.
Huh?
No, sir, you haven't explained.
I have used this term before, but you have you can't remember that. So I at very beginning I mentioned two types of voltages and induced. One is called the transformer EMF, another is called the speed EMF. You just try to recollect. So there are two types of voltage developed in the coil. One is called the transformer EMF, where the flux itself time varying. Then it is called the transformer EMF. Due to this time varying flux, whatever the voltage is induced, called a transformer EMF. But in some cases, the flux doesn't change. Flux is constant. But due to the rotation or due to the relative speed, there is a induced voltage in the coil, and that is termed as speed EMF. And if the speed is due to the rotation, then the same voltage, the same speed EMF is called the rotational EMF. Now, in case of DC machine, we generally get the rotational EMF, not the transformer EMF. As you know, the flux doesn't change in time. So therefore, only the voltage which we get for DC machine is only the rotational EMF. but the rotational EMF which we get in the coil, that should not be developed in the coil which is going under commutation. That I will explain later. Okay. Now the coil which is going under commutation, that there should not be any voltage developed. But here you see that voltage is getting developed in the coil. Now, due to this voltage, what the problem may arise? What kind of problem may arise? Now, if we start our discussion with the linear assumption like this, so this changing from IC to minus IC linearly in this TC time. In this TC time, the current is getting changed from plus IC to minus IC linearly. So this is the linear commutation. But what kind of problem may arise due to this reactance voltage, which is developed in the coil going under commutation? Can anybody tell me that what kind of change in this profile, in this linear profile?
Sir,
Sparking
this
of the pressure.
I'm not asking the derived problem. I'm asking what will be the nature of this change. Whether there will be any change
sir,
in this linear nature.
This reactance. Yes, sir.
What will be that?
Actually, the reactance voltage will try to oppose the change of current from plus IC to minus IC. So the linear characteristics will lag in time. Actually, it will bend and it will lag in time because of the opposition of the provided by the reactance voltage.
So let me explain like this. Suppose you have an RL circuit and you have an R circuit. Suppose you have an RL circuit like this. Here you have a DC voltage. Okay, and this is your RL circuit. And you have an R circuit. What is the change in the current? If I switch on at some time T0,
sir, in the R circuit, current can directly increase from 0 to the maximum value.
What is that value?
But in the RL circuit,
what is that value?
It will.
Actually, in the R circuit, the current will jump to its maximum value, but in the LR circuit, the current will gradually increase.
Now, what will be the profile?
It
now,
will be,
what will be the final current in this circuit? What will be the final current in this circuit?
Maximum value will be VC by R, but it will actually
so that means the same current will flow in both the circuit, isn't it? Ultimately,
but actually after a long time.
The time will be defined by something else, but after all, the same current will flow, na? The BC by R only.
Yes, sir.
But how it will change, that depends on what? That depends on the value of inductance. Not only that, resistance also.
Yes, sir.
So it will grow exponentially. And the curve, it comes 1 minus e to the power minus t by capital T, and this current ultimately will VC by R. Isn't it? Now this T determines how long it will take to reach the final value. And this T is therefore called the time constant. For this, it is L by R. Okay, so if the value of L with respect to R is much larger, then it will take much larger time to settle down and VC by R. As simple as that. Okay, so here also we can expect if the inductances are coil inductances are much high, then or it will not be like this. There will be some delay. Okay, so let me draw this. So there will be some delay in the commutation. So delayed commutation will get due to this reactance voltage. And this type of commutation therefore called the under commutation. So this type of delayed commutation is called the under commutation. So what kind of problem will arise due to this delayed commutation? I will discuss later. So have you understood how this delayed commutation will occur due to this reactance voltage? এই জায়গাটা ঠিক ড্র করাটা প্রপার হচ্ছে না। Let me draw more clearly. Very difficult to draw in this type of device. So this type of thing will occur due to this reactance voltage. Okay. So have you understood this point? Now to make it linear, what you can do? Do you have any suggestion? To make it linear, what you can do? If this
increase
voltage
brush increase brush width.
No. Brush width বাড়ে কি হবে বলো? Brush width বাড়ালে তো
আমি
আরো
জাস্ট নিউমেরিক্যালি ভাবছিলাম
স্যার রেজোনেট করতে সরি স্যার হ্যালো
হ্যাঁ বলো রেজোনেট কি দিয়ে করবে রেজোনেট করলে তো বেড়ে যায় আরো অ্যামপ্লিটিউড
স্যার ক্যাপাসিট্যান্স অ্যাড করা যেতে পারে
তাতে কি হবে তাতে ভোল্টেজ বেড়ে যাবে আর okay now what we can do we can nullify this voltage হ্যাঁ বলো
কমানো
স্যার এমন কি
স্যার কয়েলের ইন্ডাকটেন্স কমিয়ে
কয়েলের ইন্ডাকটেন্স কমাবে কি করে
অ্যাড করা যাতে
কয়েলের ইন্ডাকটেন্স of the coil depends on the number of turns ওকে মানে যে ফিজিক্যাল প্যারামিটার উপর যেটা ডিপেন্ড করে সেটা নাম্বার অফ টার্নসটা তো ডিপেন্ড করে মেশিন ডিজাইনের উপর মানে তোমার যেরকম লাগবে ভোল্টেজ যত লাগবে সেই অনুযায়ী নাম্বার অফ টার্নসটা ডিসাইডেড হয় বুঝতে পেরেছো তুমি মানে কমিউটেশনে প্রবলেম হচ্ছে বলে তুমি নাম্বার অফ টার্নস ডিজাইন করবে এরকম ভাবে তো ডিজাইন হয় না ডিজাইন হচ্ছে নাম্বার অফ টার্নস ভোল্টেজ দেখে ডিটারমিন হয় when you will undergo the machine design class then you will see that voltage decides how many number of turns will be there in the coil okay so what you can do this reactance voltage you have to nullify by another voltage okay so this reactance voltage you can say this
brush contact drop কমিয়ে বাড়িয়ে দিলে
বলো বলো
brush contact dropটা যদি বাড়িয়ে দিই মানে ব্রাশ রেজিস্ট্যান্সটা যদি বাড়িয়ে দিই তাহলে ব্রাশ কন্টাক্ট ড্রপটা বেশি হবে
তাহলে তো রেজিস্ট্যান্স কমিউটেশনে আরো তো প্রবলেম হবে
তো ওইটা তাহলে রিঅ্যাকট্যান্স ভোল্টেজটার উল্টো দিকে আসবে
সামহাউ যদি আমরা এই যে মানে ইন্ডাক্টর তো অ্যাকচুয়ালি ভোল্টেজ ইনডিউস করে অ্যাকচুয়াল মানে ফ্লোটাকে নষ্ট করছে যদি ওই ভোল্টেজ ইনডিউসটা আমরা অপোজিটে কোনো রকম কোনো ভোল্টেজ সোর্স দিয়ে নালিফাই করি
হ্যাঁ কারেক্ট that should be the approach if that voltage is opposed by another voltage বুঝতে পেরেছো মানে when it is flowing the current so this is the voltage developed so this is your ER which is equals to LDI dt হ্যাঁ, তুমি যদি এখানে আরেকটা সোর্স কানেক্ট করতে পারো which is in opposition with that, তাহলে you can minimize the problem due to this ER. So another voltage you have to develop. I don't know how, but some voltage you have to develop which will counter this reactance voltage. Okay, are you getting this point? Now
Yes, sir.
this reactance, this voltage. Now you just tell me this reactance voltage. Leave it this EC. Leave this EC now. This reactance voltage ER1. What type of voltage is it? Is it transformer EMF or speed EMF?
Sir, rotational.
Speed EMF, sir.
Is it speed EMF?
So transformer EMF, because current is changing.
Correct. Is the transformer
Flux
EMF?
is changing.
Is the transformer EMF? So therefore LDIDT you are getting. So I told you very clearly that when the current itself changing, that gives me us the transformer EMF. But in rotational EMF, how do we get this? LDIDT.
Relative motion between the.
Correct. So that means we don't write this. We generally in terms of n d phi dt we write, and from that we write n d phi d theta and d theta dt. Okay, so here your velocity comes, or the angular velocity comes. So this is how you get the rotational EMF or speed EMF. So you have to understood these points very clearly, because these things I have discussed very introductory classes, isn't it? So you should understand this point, the reactance EMF and this transformer EMF and this rotational EMF. So this is already we are getting for this transformer EMF. Transformer EMF. And if we can nullify this by some rotational EMF, then our objective will be fulfilled, because transformer EMF already is generated and in a certain direction. So if we want to add some another transformer EMF, so that will be additive with this. So what we can do, we can generate some rotational EMF which can counter this transformer EMF. So how this rotational EMF is generated? Generally, what I have already pointed out, that in the commutation place, there should not be any voltage, rotational voltage in the coil, but this reactance voltage initiates that rotational voltage. So we should have some rotational voltage in the place of commutation to counter that. So therefore we will allow some flux or some rotational EMF at the commutation place. Okay, and let us take that rotational EMF. You know that it can be written as BLV sin theta. Where theta is the angle between the surface of the commutator and the direction of the flux. Generally, for this case, it is 90 degree. Okay, so flux is going like this, and commutation is and the velocity is in this direction. So it is almost 90 degree. Okay, so we can write the commutation voltage is sin 90 is 1. So this is the voltage developed, can be developed in the coil going under commutation due to additional flux present at the commutation place. Any question? Okay. So that means to get exact cancellation or to get linear commutation, to get the linear commutation, this is the criteria. So there should be exact cancellation between this reactance voltage and the EC, the rotational EMF. Okay, it is also called commutation voltage, EC. EC is also called commutation voltage. So there should be exact cancellation. Okay. Have you understood this point? Any doubt? Okay. Now, so that means we can write what is the expression of ER1? So K2 VA. So that means K2 VA should be equals to the value ZC BC L VA. So VA can be cancelled, and from this we can say that this BC should be proportional to this IA. This is very important point.
Sir, why ZC comes? Please explain that again in the expression of EC.
ZC is basically coming from the number of turns.
Oh, okay.
রোটেশনালে তোমরা পড়েছো না এটা? এই যে n ডিভাইড dt থেকে আমি প্রথম দিকে যে এক্সপ্রেশন ডিরাইভ করেছিলাম, দেখে ওখানে মনে করে দেখো।
হ্যাঁ স্যার
n phi ওমেগা sin থিটা, অ্যাকচুয়ালি বিএলভি sin থিটা করেও লেখা যায়, আবার যেভাবে আমি করেছিলাম সেভাবেও লেখা যায়। সেইখান থেকে এই এনটা থেকে বেসিক্যালি জেডসি আসে। নাম্বার অফ টার্নস আর জেডসির মধ্যে একটা রিলেশন এস্টাবলিশ করে দিয়েছিলাম। Okay, so this is very important point because this BC, for ideal case, this BC should not come. The flux density at the commutation place should be ideally 0, because the commutators generally placed at such a place where you have the neutral, magnetic neutral. বুঝতে পারছো? That means, let me tell you this. Suppose this is North Pole and this is the South Pole. Okay, now where we should place the brush? We should place the brush exactly at neutral. I will explain it later why we should place the brush exactly at neutral. So that means we always try to place the brush where there is no flux at all. But here what we are doing, we are inserting another flux here, which will cancel. Otherwise there will be no this commutation voltage, no voltage like this. Okay, so additional flux we are arranging here by this BC. So the BC is the flux density. So that means here we should have some flux. In this point we should have some flux which will give me some BC, and that BC should be proportional to the armature current. Okay. What I will do, in the next class, I will start the armature reaction. Otherwise, you have some, you'll face some problem understanding this commutation, I think. Okay, the next class I will start the armature reaction. I know that you are facing some problem understanding this commutation, isn't it? Am I right? কি বুঝতে পারছো তোমরা? কমিউটেশনে যেগুলো আমি ডিসকাস করলাম আজকে,
স্যার
ইয়েস স্যার।
বুঝতে পারছো না পারছো না? ভালো করে বলো।
পাচ্ছি স্যার।
অল্প অল্প?
না স্যার বুঝেছি।
ওকে, বাট নট অল। সবার একটু অসুবিধা হচ্ছে আমি জানি, বাট ইউ শুড লিসেন দ্য ভিডিও after this class carefully. Watch the video carefully to understand these things, because books, not in all books you will have this type of analysis. Some part of this analysis you will get in the book, but not the total analysis. So that is the problem. So you should attend the class carefully, and if you missed something, then you should watch the video carefully so that you can understand this. Okay, so I will not continue today. I'll continue in the next class. The commutation has not completed yet. I need one more class to complete the commutation process. But I realized that I should discuss the armature reaction a little bit before completing this commutation. Then you will understand these things more clearly. Okay, so let me take the attendance. Then I will stop the class. Stop sharing. I will just call you roll. Where is the mic? Okay. Monica Bishas, present. Aritro Mojumdar, present.
Yes, sir.
Gopal Medda, present. Swarnodip Saha, present. Sushobhon Sarkar, absent. Orkoprabhu Haldar, absent. Arnob Chakraborty, absent. Shayan Kumar Nag, present. Megha Ghodai, absent. Arijit Mondol, absent. Himadri Das, বিশাল বর্মন, তুমি কি ক্লাসে ছিলে? বিশাল বর্মন, are you there in the class? বিশাল বর্মন, okay, so let me continue. So Arijit Mondol is absent. Himadri Das is absent. Ahan Basu, present. Piyush Agarwal, present. Shahil Singh, present. Abhirup Sarkar, present. Shoikat Das, present. Pushpal Banerjee, present. Orkoprabhu Nandi, present. Okay. Orkoprabhu Nandi. Then Joshimuddin Mondol, present. Joshimuddin Mondol.
Yes, sir.
তুমি ক্লাস করছো না রেগুলার?
Yes, sir. হ্যাঁ স্যার বলুন।
শুনতে পাচ্ছি।
হ্যাঁ আমি তো বলে দিচ্ছি তো।
হ্যাঁ করছি স্যার।
কোথায়
আমার
করছো
এখানে
তুমি?
রাতের দিকে একটু বিজি থাকে।
হ্যাঁ বলো, ক্লাস করছো না তো রেগুলার? তুমি তো দেখছি মানে প্রায়
আচ্ছা বলুন, শুনতে পাচ্ছি।
তিনটে পরপর ক্লাসে অ্যাবসেন্ট।
মানে স্যার আমার ওই নেটওয়ার্কের জন্য মাঝে মাঝে কেটে যায়
না
ক্লাসগুলো,
কেটে যাওয়ার
জয়েন
জন্য
করতে
না,
যাওয়া হয় না।
হ্যাঁ তুমি তো
আমি
প্রেজেন্ট,
ক্লাস
তুমি
অ্যাটেন্ড করি মাঝের দিকে।
কোথায় থাকো তুমি?
হ্যালো
হ্যাঁ কোথায় থাকো?
স্যার, বাঁকুড়া।
আচ্ছা,
এই বাঁকুড়া গ্রামের দিকে।
সায়কাট্টা প্রেজেন্ট, অয়ন কুইরি
মানে আমাদের
প্রেজেন্ট।
এখান দিয়ে টাওয়ারটা একটু মানে
বুঝতে পারছি। রাজদীপ সামন্ত অ্যাবসেন্ট। ওকে। দৈপায়ন গুহ প্রেজেন্ট। পুষ্পল তরফদার প্রেজেন্ট।
প্রেজেন্ট স্যার, প্রেজেন্ট স্যার।
হ্যাঁ কে?
প্রেজেন্ট স্যার,
কে?
প্রেজেন্ট স্যার।
কে বলছো?
আর পুষ্পল তরফদার।
হ্যাঁ দিচ্ছি তো প্রেজেন্ট। রাইসা চ্যাটার্জি প্রেজেন্ট।
ওকে ওকে।
রাইসা চ্যাটার্জি কোথায় গেল?
Yes, sir, present.
নির্মাল্য নন্দী প্রেজেন্ট।
Hello.
দেবাঞ্জন সরকার প্রেজেন্ট। সময়িতা চৌধুরী প্রেজেন্ট। অভিজিৎ দৈপায়ন পাল প্রেজেন্ট। শামীম হক প্রেজেন্ট। বিশাল বর্মন প্রেজেন্ট। বিশাল বর্মন ছিল। অগ্নিব অগ্নিব চ্যাটার্জি, অগ্নিব চ্যাটার্জি প্রেজেন্ট। আবু সাইদ শেখ প্রেজেন্ট। আবু সাইদ শেখ। আনন্দ চক্রবর্তী প্রেজেন্ট। দেবরাজ ব্যানার্জি প্রেজেন্ট। মৌসুমী সোরেন প্রেজেন্ট। আলামিন ইসলাম অ্যাবসেন্ট, না প্রেজেন্ট। মোহাম্মদ কি এটা? মোজাবের আলম মিদ্দা নাকি? অ্যাবসেন্ট। আমিশা পারভিন প্রেজেন্ট। জয়ত দত্ত প্রেজেন্ট। সুস্মিত রুদ্র প্রেজেন্ট। রবিন চালক, রবিন চালক অ্যাবসেন্ট। ঋষভ মহাজন, ঋষভ মহাজন আছে?
Yes, sir.
কে কে বলছো?
Sir Rishabh.
ঋষভ প্রেজেন্ট। আচ্ছা।
Sir Rishabh, roll number 63.
অরিত্র মাল, অরিত্র না দেখতে পাচ্ছি না। রূপলেখা রায় প্রেজেন্ট। ঐন্দ্রিলা হালদার, ইন্দ্রিলা হালদার কোথায় আছে? ঠিক আছে, নাসরিন। রূপসন্দা হোসেন প্রেজেন্ট। অনুভব রায় প্রেজেন্ট। পৌলমী দাস প্রেজেন্ট। রুদ্রনীল সর্দার অ্যাবসেন্ট। অভিজিৎ দাস, অভিজিৎ দাস কোথায়? নেই, অ্যাবসেন্ট। মঞ্জুর আলম মিত্রে প্রেজেন্ট। নয়ন সোরেন প্রেজেন্ট। রাজস্বী ভট্টাচার্য প্রেজেন্ট। জ্যোতিরিন্দ্র সরকার প্রেজেন্ট। স্বস্তিক কাঞ্জিলাল প্রেজেন্ট। শাশ্বত মুখার্জি অ্যাবসেন্ট। বিনয় কুমার প্রেজেন্ট। মোহাম্মদ ইউনুস আহমেদ প্রেজেন্ট। শাশ্বত মুখার্জি অ্যাবসেন্ট। আর এটা কি জানো? K. Hembram, that is also absent. Okay, so I have taken the attendance.
Sir, I'm present, sir.
Okay.
Sir, roll number 81.
Roll number 81. হ্যাঁ জ্যোতিরেন্দ্র সরকার দিয়েছে
81, হ্যাঁ।
হ্যাঁ দিয়েছে ঠিক আছে
Oh, yes, sir.
Okay.
Thank.
So, okay, so let me stop